Hello. This now we're going to discuss about the Liang barsky line clipping algorithm. Before that, we should know what exactly a line clipping algorithm does. So assume that this is a window, okay? Like you can imagine this as the camera, and like there'll be many lines over here, like one, two, many will be here. Okay, but we just want the part which is confined in the window. So we can see clearly that the part confined to the window would be somewhat like this. Over here, over here, and over here. Right, you can see that clearly. So how do we get from here to here? Obviously, we apply an algorithm. There are two very known algorithms. One is Cohen-Sutherland algorithm. Second one is Liang-Barsky algorithm. Liang-Barsky algorithm is considered better. You, if you read about Cohen-Sutherland algorithm, then you would notice that Liang-Barsky does sound definitely better and works better also. Let's see how it works. I think now you must have got the idea of line clipping and what it means. Let's see how it works. Okay, so this line basket algorithm, this is the algorithm. First, we assume some u min and u max. We set the u min equal to 0 and u max equal to 1. Okay, then we calculate u values. Actually, there are 4 u values: u left, u right, u top, u bottom. We'll see. There's a formula. I'll tell you about it. Then we check if the u values we found, like u left for example, is greater than u min, or if u, like whatever the u value is found, is greater than u max or not. If these values satisfied, then we ignore the value, then we just consider it. If u min less than u max, then draw a line from x naught is the first first point of the line. Like for example, if this is a line, then the line we want to clip, this is the first part, x naught. Okay. Then x naught plus del x into u min. Del x is nothing, just difference of x coordinates over here. Similarly, del y is nothing but difference of y coordinates over here. Now from the first point, the line clip will be x naught plus del x dot u min, comma y naught plus del y dot u min, to x naught plus del x dot u max, comma y naught plus del y dot u max. Now for example, we can consider this line. Here we can see 0, 10, 10, 10, 0, 0, 10, 0, end point. This is the window. This is the line. Okay, from minus 5 to 3 to 15, 9. Okay. Now obviously, as discussed, now you can guess that what we want. We just want this part over here. We don't want the other parts, and just we want a formula to like calculate so that you'll just consider these points and you'll just ignore the other points. So basically, your output will be somewhat like this. Yeah, just we won't consider these points. So how do we get from here to here, like I was saying? Now look at the algorithm again. Said u min equal to u max equal to 1, that we did. Now I have u values. Now I told you about u values earlier. There's were u left, u right, u top, u bottom. U is actually with respect to this, like this value we calculate some value, we put a formula, we calculate a value. This value is considered u left, this is considered u right, this is considered u top, this is considered u bottom. Okay. Now let us look at a logical point of view. Not logical, more like a sophisticated thing. The line is from here to here. Okay, so definitely we should get a proper value for u left and a proper value for u right. We shouldn't get a proper value for u top and u bottom. Like for example, if the line goes from here to here, from here to here, then obviously a u top, u bottom. Which is from here to here, then a u top and u right. Okay, you get it right? So yeah, so what did we do? We need u left and u right proper values. Let's first calculate u left, the formula. The formula for u left is x naught, the first coordinate, minus x u min as 0 by del x. Del x is the difference. Input the formula, we get 1 by 4. You put the formula, you'll get the value. Now we calculate u right. Now I forgot one thing. 1 by 4, does it satisfy this? Yes, it does. 1 by 4 less than u min. But 1 by 4 less than u min, or wait, sorry, 1 by 4 is greater than u min and 1 by 4 less than u max. So yes, 1 by 4 is greater than 0, 1 by 4 is less than 1. So yes, it satisfies. So we consider this value. Okay, we just mark this. Okay, now u right. The u right formula is x u max minus x naught by del x. Now it's clear, x Now here x is this coordinate. X is this coordinate. I mean, x is this coordinate. Okay. Now it's if you think of a logical point of view, when we go from here to here, the y coordinate doesn't change. You can see 10 comma 10. The x coordinate only changes. That's how we do it. So x coordinate we consider this coordinate 10. Now again over here also you might see an x over here. Yeah, over here x. Now if now this x coordinate actually 0, but since 0 into 0 is 0, so we don't consider that. So you got the gist right. X u max minus x naught by del x. When you put the formula, you get 3 by 4. Does 3 by 4 satisfy the condition? Yes, it does. 3 by 4 is greater than 0. 3 by 4 is less than 1. So it does. Let's mark this also. Okay. Now let's say u bottom. For u bottom, y naught minus y min by minus del y. Now, y naught again. Y naught again is this one. Yeah, this. Sorry, this. Y naught this. And then we calculate. We get a value called minus 1 by 2. The minus 1 by 2 doesn't satisfy these values because minus 1 by 2 is less than u min is 0. So minus 1 by 2 less than u min, so we ignore this value. Okay, I, as we ignore. Similarly, we calculate for u top. Again, we put the formula u max minus y naught by del y equal to 10 minus 3 by 9 minus 3 equal to 7 by 6. Again, y naught will be 10 over here. Sorry, y naught will be 10, correct, 10 over here. So we calculate again 10 by 7 by 6, we get 7 by 6. Now I know y naught and x naught may seem a little bit confusing, but if you understood this part, like when I said about the x naught, then you should be able to consider this part also, where you should be able to calculate y naught also. No problem. We get a value 7 by 6. Now 7 by 6, does it satisfy the condition? This satisfies this condition. 7 by 6 is u max. So when this is satisfied, then ignore it. So we ignore this also. Now we have all the 4 values. Now what did it say? We want to calculate a u min. Again, we want to calculate a new u min and a new u max. So 1 by 4, we got 2 proper values, 1 by 4, 3 by 4. If it's a proper line clipping, you always get 2 values only. Remember this. Okay. And if we get 3 values or 1 will satisfy u greater than u min and u less than u max, the formula is wrong. Okay. And now I get these 2 values, 1 by 4, 3 by 4. 1 by 4 less than 3 by 4. So this can be considered as a new u min. New u min. This can be considered as new u max. Okay, now new u min, u max is found. Now if u min is greater than u max, of course 1 by 4 is less than 3 by 4. Then we draw a line from x naught plus del x dot u min plus y naught plus del y dot u min to x naught plus del x dot u max, comma y naught plus del y by u max. Now del x and del y nothing. There's a difference in points, like minus 5 comma 3 is over here, 15 comma 9 is here. So if we consider this 20 comma 6, 15, if we put the formula, we get 20 comma 6, that is del x plus del y, nothing but del x comma del y. Now we draw a line from minus 5, we put the formula, substitute the values. These we get some values over here. Now these values are nothing but these coordinates, from this to this. And when we implement this, we can use our own. We can like either color it, or we can just remove these pixels, whatever. That's up to us, obviously. And then we get the final result as this, proper this, from here to here. Okay. So yes, we can see that the clip because we don't have this part, and yes, you might have a doubt. What if the line is over there? Then your algorithm would fail. Like you would get the null value over here, nothing would change. And if it's something like this, then there's no change, even then it will fail because it's already inside it, so you don't need to clip it or anything. It's just for cases when the line is outside the boundary and need to clip it. So I hope you like this video. Thank you.